Hey, hello guys, welcome to Network Beats, and this is Tangadurai, and it's been a long time that we have posted a video in our channel. So I took a decision stating no, I'll be posting the videos hereafter regularly, and since there are many videos available in my channel over like CCNA parts and few video about the BGP. So the my plan is now I'll be covering from BGP, then followed by the MPLS and VPLS and segment routing. These are the topics that majorly I'm going to concern about it, and I'm going to teach you guys over this channel. So I don't want to take much of your time just to brush up a BGP topic. It is just an introduction section about the BGP and a few concept about it. So once we are done with this, we will just jump into the technical concepts. So what is BGP? So BGP is a border gateway protocol, which we know, right? Okay. So why do we need BGP? When we have multiple routing protocol like RIP, which is already rest in peace, so we don't care about RIP. The other routing protocol like OSPF, EIGRP, ISIS. When we talk about these routing protocols, how BGP is different from those, right? So this is what our question is. So, as we know, we can differentiate the routing protocol into two different category. One is interior gateway protocol, and the other one is exterior gateway protocol, right? Sorry for the bad writing. I'm just using my mouse over the paint. That is why, just bear with me. Uh, Fine. So whatever I have told, OSPF, EAGRP, ISIS, everything will come under IGP, right? So what is this EGP? So EGP is Exterior Gateway Protocol. There was a protocol in past in our history, but it is currently not in use because this protocol is being replaced by the protocol something called BGP. Okay, so BGP is the routing protocol which runs over the internet. Okay, so it is the main protocol which runs on the internet uh, between the ISP networks, ISP Internet Service Provider Network. Okay, so okay, this is what a BGP is a part of EGP protocol. Since it is the only one protocol under the EGP, we'll call this as the BGP, right? We don't call like the OSPF, the EIGRP, since we have many protocol under IGP, not like BGP. Okay, fine. I don't want to confuse you guys much on this. So if you don't get this, that's fine, no problem. Fine. So next we have to uh, the question is okay, why BGP instead of using these protocols? Okay, let me write EIGRP, ISIS, right? Okay. Instead of these protocols, why we are going to use the BGP? Okay. Okay. So these protocols were mainly focused and designed in order to manage and run the enterprise network. Okay. Let's say you own the company and or you are the network administrator of the company, right? This is your company, and where you have a bunch of routers, hundreds of routers or thousands of routers, uh, which they have connected in some fashion, and in order to give the services over different part of geographical locations, right? Let's assume something like this is your network, okay? And this network is owned by this particular enterprise called Enterprise A or Enterprise ABC, Enterprise. ABC, let's say that, right? Okay. So in order to manage your routing information, or just to establish the connectivity between different geographical location, you need to enable a routing protocol on your router so that your router can pass a data from one network to the other network so that the communication can happen in on your network, right? Uh, Fine. So, if you want to choose any protocol for this network, then I would recommend go and use any of the protocol um, from the IGP category instead of the BGP. Okay, why? Because if for this particular scenario, IGP works like a champ comparatively the BGP. I'll come to that part why it is in few minutes. Okay, so here the OSPF, EIGRP, ISIS are designed for IBGP. Why? Because they are designed to handle only limited number of prefixes, not like BGP. Okay, BGP can handle like hundreds and thousands and millions of prefixes, which is running over the internet, but which is not able to handle by these IGP protocols. That is the main reason why we should use BGP over the internet, not OSPF, EIGRP, and ISIS. Great. So this is why we need BGP instead of IGP. Okay, fine. So let me just erase this. So the next part I would like to discuss what I can do with BGP, right? So BGP protocol is I have to let's say that you have two routers, okay, and you have a connection like this. Let's say that this is router A and router B. If you run OSPF or EIGRP, just you go and advertise the subnet whatever you have configured on this interface and on this interface on these each routers. Let's say that you have configured 10.0.0.0/24 network on this link. Here it is .1 and here it is .2. Okay, that means 10.0.0.1 and 10.0.0.2 on this interface. When you go and advertise these network, the network is sorry, this network on this interface and on this interface, your OSPF and EIGRP will identify this based on some mechanism, and the neighborship will happen automatically. Okay, if there are some checklists are there before forming the neighborship. I'm not going into that, but let's make it as simple. Okay, so just by advertising this network, our neighborship will be established on RIP and sorry, not RIP, on OSPF, EIGRP, and ISIS. But in BGP, let's say that uh, here I have to define in router A, I have to define who is my neighbor. Let's say that so my neighbor is 10.0.0.2 is my neighbor, and he is located on AS number. There will be because in BGP the routers are identified by the AS number which they belongs to. Okay, let's say that router A it belong to AS 100 and router B belongs to AS 200. Okay, fine. So for router A, I have to say first, okay, who is my neighbor? My neighbor is 10.0.0.2, and then I have to say my neighbor is located in which AS, right? So the second part, he is with AS 200. Okay, this information would be required from router A so that he can start establish the how he will start establish the communication to establish the neighborship to that particular neighbor 10.0.0.2. That's fine. Okay. So the other thing, similarly, router B requires, here in router B as well, we have to say, hey router B, you should know who is your neighbor, and also you should know where is your neighbor located at, which that means on which AS number, so that you can establish neighborship with router A. Without defining these things manually on these routers, our neighborship is not going to form on the BGP, right? This is the simple thing that we should know when we are talking about the BGP. Okay, here the neighbors are defined manually, not dynamically. Okay, it will not form dynamically like OSPF or EAGRP or ISIS. So this is the topic that I would like to uh, discuss. Okay, fine. So we are done with this. We'll just get to know again, like there are different things like IBGP, right? And there is something called EBGP, right? We will get into this shortly. Okay, fine. So just a thing here again for summary. In BGP, we have to define the neighbors manually. It will not form neighborships dynamically like OSPF, ISIS, or EIGRP. Okay, here we have to define it manually. Great. So the next part here, we should know like what is IBGP and what is EBGP. Simple. Okay. Let's take a router here and a router here and router here. Okay. And okay, this is router 1 and this is router 2 and this is router 3, and this is how my connection is. Okay, and router 1 and router 2 are part of one AS and router 3 is part of different AS. Let's name it AS 100. Let's name this AS 200. Okay, so when I say AS 100 means router 1 and router 2, they both belong to AS 100. When I say router AS 200, router 3 belongs to AS 200 as per this topology. Okay. Here, when I try to establish a neighborship between any of these routers, it has different meaning. Okay, if I try to establish a neighborship between R1 and R2 using BGP, okay, then this is called IBGP. Okay, and if I try to establish a neighborship between R1 and R3, this is called EBGP. Okay, how do you differentiate this IBGP and EBGP? Okay, that is what the question going on your mind, right? It is simple. Okay, there is no rocket science in this. Okay, if your routers, okay, the routers which you are considering for the neighborship, okay, here R1 and R2, or the router trying to form the neighborship, both are in the same autonomous system number 100, right? So I'm calling this as a IBGP. And here R1 and R3, they are belongs to two different AS number, because R1 belongs to AS 100, R3 belongs to AS 200. So that is why I call this as the EBGP. Okay, so in CLI, that means in router, how these things are differentiated. Okay, that means they are differentiated by AD value, administrative distance. This is, I hope you guys are aware about it. What is AD? This is main thing for routes for the best path selection if there are multiple paths available over the network, right? So let's say that for IBGP, the AD value is 200. Okay, this is not example. This is the default value for the Cisco products, IBGP. AD value is 200. For eBGP, the AD value is 20. That means whichever the prefix is advertised by eBGP is more preferable than the iBGP. Don't get confused here. Let's say that uh, this is the router, okay, and it has a iBGP peer with a router. Just assume that, and also it has a eBGP neighborship with some router, okay, and this router X is receiving update for prefix, let's say that 15 network slash 8 over IBGP, and also it is receiving update for the same 15 network slash 8 over eBGP. Okay, so router X will prefer eBGP rather than the IBGP. Why? Because the prefix is same, both are 15.0.0.0. Okay, because of the administrative distance, eBGP has only 20 and IBGP is 200. So the lowest AD value will be highly preferred. So in this case, it will prefer the update from eBGP rather than the IBGP. Clear? So this is how the AD value will play in this role. And also I hope you have understood what is IBGP and what is eBGP. IBGP means the routers belongs to the same autonomous system number. eBGP is nothing but the neighborship built between two different routers belongs to two different autonomous system number, right? Great. So let me clear this. Now we have something called okay, before going to the types of connection, I would like to share few more points about the BGP, when to use the BGP protocol and when not to use the BGP protocol. Okay, let's say this is your enterprise network, okay, which have bunch of routers, okay, and this is your ISP, okay. That means even ISP will have the routers, right? That is what it is. Okay. And you have one connection connected to the ISP. So that means like you have one exit point and one entry point to go out of your network and to come into your network, right? So whatever the request to the ISP has to go on this link, and whatever the reply comes from the ISP has to be received on this one link only. Okay, because this is the only one connection that you have on your network connected to ISP, right? So in this case, for the route exchange, it is BGP is not required for this kind of topology. So what we call in technical term is called, it is a single home network. Okay, single home network. Okay, that means it has one connection to exit and entry from and to for this network. Correct. So for this type of topology, we may not be using BGP because here you can even use a static routing in order to like route the packets to the ISP, and also you can get it back from the ISP. Okay, so the another possibility what we can do is like we can advertise the routes whatever you have to the ISP, and also you can request a default route from the ISP router, so that uh, there will be a default route on the edge router, so that by default all the router will be sending packets to the edge router, and from there it will go to the ISP. This is a simple method that we can implement on these links instead of building a BGP. Okay, so if it is a single home, you may not be required to uh, configure BGP on that router. Fine. So where I can use a BGP. Okay, before going to the topic, and also there is one more scenario where you should not use BGP. Is let's say that your enterprise router or not highly specify like it is not a high specification router which lacks a lot of memory for every processing. If it is a case, then don't choose BGP. Okay, BGP is like it it will be requiring high memory. It is you know memory plays a lot when you are running a BGP. So if your router cannot process or cannot deal with high memory, then do not choose BGP. That for that purpose, you can go to the data sheet of that particular product what you are using and just cross verify whether it will be supporting or not. Okay, in simple. So that is what when you should not use a BGP. So when you can use the BGP, let's say that if you have multiple, let's say that this is your enterprise, and let's say that you have the edge routers. Okay, and let's say that this is my ISP, and also this is one of my ISP. Okay, ISP2, ISP1. Let's say that if you have multiple connections, okay, that means if you have more than one link to go out of your network and to come into your network, right? So this is called actually multi-home or dual home. We'll be covering these concepts soon. If it is the case, then yes, you can go and use BGP, okay? And again, there is a purpose or there is a scenario. Let's say that if this is your router and you have two links, okay, let's consider like this. Okay, one is primary, one is secondary. Okay, and let's say that primary link will support 50 Mbps of bandwidth, and the secondary link has a bandwidth of let's say that around 10 Mbps. Okay, and in that case it is primary link and it is your secondary link as per your choice. So based on that you have chosen the plan whatever provided by the ISP. So in this case even without the BGP you can just build it just by putting a static route on this link, and here what you can put floating static route. What is that floating static route? Let's say that like IP, the command would be slightly differ. IP route and your destination prefix. Let's say that my destination prefix will be like 100.0.0.0, and the subnet mask of this is /24, and my next hop IP. All right, whatever it has been defined. Next hop IP. This is a static route configuration what we will be putting on our router. But if you just tweak this configuration little after next stop, if you define some number, okay, this is called AD value. We can manually assign some AD value greater than the default configuration. Let's say that this is a primary configuration and the second line is a secondary link configuration. That means like let me by default for the static route the AD value is 1, right? For directly connected routes it will be 0. For and also I have told like for IBGP we have 200, for eBGP we have 20. So based on that, you choose some decent the values appropriately. Okay, so what is this? Fine. So here let me choose the AD value like 20 for example, not 20. Let me choose like something like 50, or it is up to you. Okay. So whenever there is a problem of, let's say that there is a link failure, or let's say that whichever the router connected here become faulty, or if this port connected to whatever it is, okay, this link is not available, there is a packet cannot move over this link. Okay, that means this configuration will become invalid and it cannot be used because your next hop IP is not reachable for so and so reason, right? So automatically, okay, your router will be taking this as a best path because your primary path is not available at this moment because of the next hop reachability. It for next hop is not reachable, right? So automatically this will become the next path. So by doing this, you can achieve your purpose over this topology. But it is not the one which we deal with the BGP. Okay. So what we do with the BGP, uh, let's say you have a router here and you have the ISP connected to it. Okay. And you have the links connected over here and here. This is router 1 and router 2 and router 3, and this is ISP network, and this is your enterprise network. Okay, and what here, how what we can do with the BGP is like, let's say that for few of the prefixes you would like to access over this link, for few of the prefixes you would like to access over this link. Let's say that an example. There are prefixes like 10.0.0.0 slash 16, okay, for example, and 20.0.0.0 slash 16 and 30.0.0.0.0 slash 24, and let's say that 50.0.0.0 slash 0 slash 28. Okay. So these are the networks you are trying to, these are the destination networks you are trying to reach. Okay. So what you can do here is for these networks, okay, whichever marked in red, right? For these networks, okay, you can use R1 to R2 connection, okay, and here you can use, okay, I didn't copy 30.0.0.0 24 50 000 slash 28. Okay, for these two prefixes you can reach over this link. That means there are many benefits. Okay, that means you are in the previous scenario, right, when you have one link as primary and other link as a secondary, you are too much loading one link, right, the primary link. Once this primary link is not available, then only you are going to use the secondary link. Okay, let's say that your primary link is not going down at all. Okay, it is perfectly running good, but it doesn't mean that you are not going to pay the premium to your ISP for this secondary link, right? Anyhow, you have to go and pay it. Okay, so here you are not using this brand bandwidth efficiently for the secondary link since the primary link is doing good. In that case, your premium that what you are paying is like it is like loss for you, right? Because you are not using it properly. But using BGP, what you can do, you can efficiently use both. I don't say it is primary or secondary. You can use both of these links, right? By doing path manipulation, uh, like we used to call this is called PBR, policy based routing, right? You have the control over the network, which prefixes has to be routed over which link and which prefixes has to be received over which link. Okay, this can be done by BGP. So this is a great advantage of using BGP in our network. Okay, and also we know a BGP is a path vector routing protocol. Path vector routing protocol. Okay, what does it mean? Okay, path vector, that means it is direction oriented. Okay, let's say I have these are not clouds, these are different AS. Okay, think like that. Okay, and this is AS 100, this is AS 200, this is AS 300, and this is AS 400, and this is AS 500. Great. And you have that means this have the bunch of routers, okay, in these AS, and we have the connection between each routers from these AS, and we have the topology something like this. Okay, okay. If you're confused, let me draw the router something like this. Okay, and there will be interconnection between these routers since like IBGP, since these the routers whichever I have drawn inside an AS, right? They will be IBGP, and the router from two different AS will be a EBGP connection, right? So that is what we have learned. Okay. Really, it is really a tough to draw over the paint using the mouse. Okay, just bear with me with this horrible diagram. Okay, let's say that, okay, this router here, okay, he is advertising prefix 155.0.0.0 slash 28. Okay, when this prefix is advertised to this router, where it is advertised to this router, this update contains the prefix 1, contains what? It has a prefix information just like the other routing protocol, how they update. And also there is something called path attribute. Okay, it contains the AS path information. Okay, this prefix is originated from AS 100, correct? Okay, now when this update is passed in over IBGP to this router, and when this router got that update, he'll be trying to update that information to this EBGP peer. Am I right? I'm not confusing, right? Okay, because this belongs to AS200, this belongs to AS300. That is why I call this as a EBGP peer. And now what it updates, right? It has 155.0.0.0 slash 28, which is prefix the subnet information, and also it has something, okay, uh, something called path attribute information, what I have told you just before. Okay, now it is little bit changed here. Okay, what it has changed, initially it originated from 100, now it has come to 200. Now from 200, AS200, when it is advertising to the AS300 router, it also includes AS200 information in that particular prefix, right? So that there is a track how this prefix has been traveled through how many AS, right? Okay. Similarly, when this update is coming to this AS, it will be having something like this. 300 will be included in that AS path attribute. Okay, when this router updates it to AS500, now it looks like, okay, 400 will be added. What happened? Okay, okay, while sending the update. When this is sent it again back to AS100, now AS100, this router will be thinking, okay, I see AS100, okay, that means this is the how the update will be here. Okay, it will be something like 500 and then 400, right? Okay, so that you guys will not be confused. Okay, so this is what the update would be sent by AS500. So now this router, it will think, wait, okay, this prefix is come from AS100, 200, 300, 400, 500, right? But this router itself is sitting on AS100. Why I should take this update from you by using this many hops away? Like it is the longest path, right? Because he can reach that prefix uh, through AS100 itself instead of going like this, correct? So this is what a loop, right? This is how BGP prevent the loop which is relevant over eBGP protocol, right? So this is a loop prevention mechanism with the BGP. Hope it is clear. Okay, so this AS path attribute will be tracked whenever the prefix is crossing every AS, and if a router sees that its own AS present in the AS path attribute here value, then that particular update will not be considered by that router in order to avoid the loop. Okay, thanks for watching, guys. I will be posting the next video soon. Stay safe, be healthy. Bye. See you.